Listen children, third chapter matrices transpose of matrix we are going to see. First we will see the definition of transpose, then we will go. Okay, so transpose of matrix in the sense, matrix we know that 1 2 3 we have. Okay, suppose if you have like this now, the row will be writing as a column matrix. This transpose like a t, power t they will be mentioned, or just a dash they will denote. Either this or that you can use. Suppose t I'm mentioning now, the row we have to write as a column. Next second row we can write as a second column. That's it. So that 2 by 3 will be changing into 3 by 2. The row will be interchanging the place. Okay, 2 will be going to 3 places, 3 will be coming to 2 places. So number of row, that row and columns will be interchanged. Even the row also will be changed, number of row also. 2 by 3 means 3 by 2 you will be getting. That is called the, what is that, transpose of a matrix. Means rows and columns will be interchanged. How we will be writing that officially we will see. So what I'm writing, just you copy children. If a equal to aij, a equal to aij be an m by n matrix. M by n matrix. M by n matrix in the sense, m rows and n columns is the meaning. If you take transpose, the m by n will be interchanged into what? N by m. Row will be changing into column, right? That will be interchanged. Be careful. Right, fine. So how we can go then? The matrix, obtained by interchanging, interchanging the rows and columns. Okay, that's it pa. Rows and columns of a is called what we can say, transpose of the matrix. Is called the transpose of the matrix. Transpose of the matrix. Transpose of the matrix. Transpose of the matrix, or transpose of A also you can say, or transpose of the matrix A also you can say. That's it. Understand? Right. Which is denoted, transpose of matrix denoted, I'll write here down. Transpose of matrix. Transpose of the matrix A is denoted by either A dash or A power T. That is, you want to read that A transpose or A power T, not an issue. Yeah. Yes, I will show. Wait. In interchanging, what happened? Interchanging. Am I right? Right. In other word, Raja, in other word, the what I said, m by n by m you will be getting m, right? That is also, what is that we have to mention. The other word, what? If A is equal to a matrix Aij, order m by n in the sense, then A dash or A transpose equal to A ij not A j I, means row and column will be interchanging, right? Here already we have discussed, I means row, j means column. Like that we have discussed, right? Here that j will be coming first, I will be going next. That also will be interchanging. Even order also will be interchanging. Means n by m. Like that you will be getting. Understand? So example, simple example I will give. Suppose example A equal to 1, 2, 3, 4, 5, 0. If I am taking A matrix now, then A transpose, that is A dash, which is equal to 1, 2, 3 row. The first row I am writing as a column. Like that, 4, 5, 0. Here we have 2 rows, 3 columns, but here we have 3 rows and 2 columns. That's it. That is very important definition. Transpose. Even the same thing will be useful in the fourth chapter also. Means in the determinant chapter also it will be useful. The transpose concept. You understand this. Next we are entering in the properties of transpose of the matrix. All the topic we have some properties, right? Addition also we have some property. Orders would be what is the same. Even subtraction also like that. And corresponding element we have to add. And product now we have seen that what is that order must be exist. First matrix what is that column, second matrix row must be same, then only product will be exist. Like that we have some properties for each. Same manner transpose of matrix also we have a property. Boy side over up, girl side ma right. Let's go to the property. Let's go to the properties of, write the topic, properties of transpose of a matrix. Transpose of a matrix. Transpose of the matrices or a matrix. Right. So this is the topic. First one, what? Suppose A be the matrix. Okay. Let A and B are two matrices. Then what is the properties all will be satisfied. What is that? Formula number 1. If you take A transpose, the whole transpose, you will be getting the A. That I'll give example. For each, I'll give examples. Raja, just listen. And second one, or else example don't want, just see. Second one, directly will go. Scalar. When we have a scalar, if you take a transpose, K you can multiply inside, later you can take a transpose, or K you can leave it. For matrix alone, you can take a transpose. Also correct. And second one, when we have addition or subtraction. When we have addition or subtraction, if you have a transpose, as it is, we have to apply A transpose plus B transpose. Separately find a transpose, add, or add and find a transpose, you will be getting. Okay. Sorry, this will be third one. And same manner, fourth one. Fourth one, what? Product of the AB. When you take a transpose, it will be interchange the place B dash A dash. See children, if you take the transpose as it is, A dash B dash, it not necessarily be equal. It not necessarily be equal. Understand? Don't forget. So when you product the matrix alone, matrices we have to interchange when you take transpose. This four what is that properties we have. For each what is that, based on each property we have a separate sums in the exercise. Examples and all we will see in the sums. Directly we will see in the sums. Don't want to give now sums separately. Next topic what now? Symmetric and skew symmetric. Symmetric and skew symmetric. So that symmetric matrix and skew symmetric matrix. Symmetric, skew symmetric matrices. So next topic we are moving. Symmetric and skew symmetric. Symmetric and skew symmetric topics. So very simple. The definition is very simple. Symmetric means when you take transpose, if you get same question, when you take transpose, same question if you get, that is called symmetric. Example I gave like that, 1, 2, what is that, 2, if you have 3 here, this is, suppose this is A matrix. Simple example I'm giving. If you take a transpose now, see the row you write as a column 1, 2. This row you write as a column 2, 3. See again it is look like a same question. So A dash equal to A, if it is comes in, that is called the symmetric matrix. Okay, when you take transpose, question is not changing. Again I'm getting the same question, means it's called the symmetric actually. Skew symmetric means what now? We have a 0, 2 and what is that, minus 2, 0 like this, or anything else. Okay, like this if we have means this is A matrix. When you take a transpose, what I'm getting here, see, this one you write as a, what is that, column. This one you write as a column. So this is I'm getting. Now if you want to bring question now, you can what is that, take minus outside. When you take outside, inside element and all, you will be getting opposite sign. 0 will be whatever the same. It will be plus 2, it will be minus 2, it will be 0. Now see again, which is look like a question. So that this one we can say that what, minus A. So when you take a transpose, if you get minus A, which is called the skew symmetric matrix. What is that? We can say that which is a skew symmetric matrix. So skew symmetric matrix 1, you can note down that diagonal elements must be 0. Have you noticed it? Skew symmetric now, it will be, what is that, diagonal element will be 0, as well as when you take transpose, you will be getting minus A. But symmetric means you will be getting question as it is. That is, I am going to write as a definition now. Understand? Just write what I am writing now. First, a square matrix they are taking. Square matrix means symmetric and skew symmetric must be what, actually square matrix. Other matrix and all not applicable, either 2 by 2 or 3 by 3. Okay, for us up to 2 by 2, 3 by 3 only. So don't want to worry. A matrix, what is that? Matrix A is equal to Aij is said to be symmetric. Is said to be symmetric now if it should be satisfied A dash is equal to A. When you take transpose, it must be same question. That is, sir, this is important condition, sir. After if condition, that is important one. A dash equal to A satisfied na, which is called symmetric. Okay, that is same you will be getting. Example I will give for this. Example, simple example I will give. Okay, A equal to 1, 2, 3, 2, 3, 4, 5. This will be 5 and 6. So this matrix I am taking. Some own number I have given here. So if you take a transpose for this, you will be getting again what, actually same A only. Then A dash is equal to what? Now see the, what is that, first row you write as a column. So 1, 2, 3. Now second row 2, 4, 5 you write as a column. 2, 4, 5. Now third row 3, 5, 6 you write as a third column. 3, 5, 6. You can note down that it will be what, same question it is up here there. Am I right? So that this one, what we can say, symmetric we can say. What we can say? Symmetric. So skew symmetric now you will be getting negative, you will be getting. Okay, skew symmetric I will write here. Skew symmetric I will write here. Same only, that also must be a square matrix. So this one you give one star for first matrix, second star for second definition. A square matrix A is said to be, okay, a square matrix A is said to be skew symmetric matrix. Okay, is said to be skew symmetric matrix if what condition? Very important condition. A dash is equal to minus A. A dash is equal to minus A should come. Example I will give. Simple example I will give. A equal to, what is that? 0, 1, 2. Here you will be getting a minus 1, minus 2, 0, 3. Here minus 3, 0. Like this I am giving. This is the A matrix. If I am taking a transpose for this, what you will be getting? A transpose is equal to that row 1 I have to write as column. So 0, 1, 2. Again second row you write as a column. So that minus 1, 0, 3. Now third row you write as a column 3. Means minus 2, minus 3, 0. Children, in this, in the matrix, after taking the transpose, if we take negative outside, what will be happen? All negative element will be positive, positive element will be negative. So that 0 will be 0 as it is, but minus 1 will be positive, plus minus 2 will be plus 2, like that. Minus plus 1 here, minus 1, sorry, plus 1 is there, so it will be minus 1. This is all plus, so it will become minus then. Okay, so that minus 2, minus 3, here 0. Minus 3 and 0 will be plus 3, 0. Okay, plus 3, 0. So what is this? Have you noticed? Again, this is a question. Have you noticed it, children? So that what we got then? What we got then? Which is equal to minus a. Okay, so therefore, a dash equal to minus a. We can say that what? Skew symmetric matrix. That's it. This is the definition they are giving here, and a few more. Two more theorems are we have, very important theorems. Based on that, even we have sums also. So theorems will go. Before that, you complete this. So you have to memorize that 2 point here. What? 2 point you have. What is that? You have to memorize. So symmetric na a dash is equal to a. Skew symmetric na a dash is equal to minus a. Very very important note. They may ask in the MCQ also. Okay. And one more important thing. Skew symmetric na, what happened? What about diagonal element? What about diagonal element? 0. Very important note that also. Okay, these two things you have to remember in your point. Shall we go next, ba? Have we done these things? Boys side, ma? Girls side, is anyone writing? Right. So next, theorem number 1. What is theorem number 1? Let's see. Theorem number 1, I will write as a, what is that? You just copy it, Raja. Theorem number 1. What is theorem number 1? First, we'll write the question. For any square matrix A with real number entries, A plus A dash is a symmetric matrix, like that. What is that? A minus A dash is a skew symmetric matrix. Okay, very important pa. Listen, when this is applicable, when we have a real number entries, means inside, if you are taking a matrix 1 2 3 4 5 na, so we can say that it will be A plus A dash na, we can say that symmetric. A minus A dash na, we can say that skew symmetric, we can say. I mean, what I'm telling, sometime they'll give matrix A they will give to Raja. Listen, they'll give A matrix, and they will ask to find symmetric matrix. Symmetric matrix, if they ask to find na, what you have to do? You find A dash, and add with A. You will be getting the, what is that, symmetric matrix. Suppose skew symmetric, if they ask na, A dash you find, what is that? You have to subtract from A. Then you will be getting skew symmetric matrix. Listen, A they will give. How the theorem 1 going to use na? A they will give. They will ask to find a symmetric matrix. You have to find A dash separately. Then A dash we have to add. Then you will be getting the symmetric. Like that, A dash we have to find separately. Then we have to subtract the A dash from A. What is you are getting answer? That will be skew symmetric, surely. Means the column you will be getting 0. Surely you will be getting. If you have a doubt, I'll just show you. So if you take a transpose now 1 2 3 4, you will be getting, this is A dash. So now you subtract A minus A dash, what I am getting? A means what here? 1 2 3 4. So if you subtract 1 3 2 4, you subtract what I am getting? See children, 1 minus 1 what? 0. 2 minus 3 what? Minus 1. 3 minus 2 what? 1. 4 minus 4 what? 0. Okay, skew symmetric matrix. Now, what we said, diagonal element must be 0. Yes, we got it. Diagonal element must be 0. And one more thing, if you take a transpose, surely you will be getting minus A. Minus A, na, this is now A matrix. This is now A matrix. If you take a transpose for this, you will be getting minus of A. You take a transpose for this, 0 minus 1, 1 is 0. Am I right? Take minus outside, what you will be getting? 0 minus 1, 1 is 0. So see that this will be again here. So that minus A. So if you take a transpose, I am getting minus A. Have you noticed? Have you noticed? Listen, otherwise you will not understand anything. Okay. So skew symmetric matrix, na, they will give A. If they ask to find a skew symmetric matrix, na, A minus A dash. You have to find A dash and subtract both. That is called a skew symmetric. When you add both, which is called symmetric. Very important note. Okay, 3 mark question they will be asking. So very easily I have done in the 2 by 2, but they will give 3 by 3. It will take time. Okay, 3 by 3 matrix they will give in a 2 mark or 3 mark. You have to do carefully. Understand? So symmetric, skew symmetric finding work is very important. When you add A dash, what is called bar? When you add A dash, what is called symmetric? When you separate A and A dash, skew symmetric matrix. Okay, right. Without a proof, you just take this bar. Don't want to proof. Next theorem number 2. Next theorem number 2, Raja. Theorem number 2 we are moving. Raja, theorem number 2. Any square matrix here, any square matrix can be expressed as the sum of symmetric and a skew symmetric matrix. Listen what they are telling here, children. Listen what they are telling here. Listen, that is what is the meaning of the statement. You will see, any square matrix you take, that can be expressed as sum of symmetric and skew symmetric. They are telling. Symmetric means what actually? A plus A dash. Skew symmetric means what? A minus A dash. If we add these two, we can express as a square matrix. Any square matrix we can express as sum of the symmetric and skew symmetric. When you add both, symmetric, skew symmetric, when you add both, it will be coming any square matrix. They are telling any square matrix na A you will be getting. They are telling. Shall we check once again? See, plus A dash minus A dash cancel. A plus A what? 2A we are getting. What we are getting? 2A. But what we need to get? A. But 2A we are getting. So if you have divided 2 cancel, you will be getting A. Am I right? So that the divided 2 I am giving here as well as here. So if they are given symmetric matrix and skew symmetric matrix, if they are asking to find matrix na, what we have to do? Multiply 1 by 2 in both the place and add both, you will be getting the matrix A. Understand? So this is as a formula they are giving in the theorem 2. That is the formula they are giving as a theorem number 2. So that is A is equal to half of A plus A dash plus half of A minus A dash. Okay, so here you can note down one thing. Listen, children, here you can note down one thing. Sir, you have said in the theorem number 1, A plus A dash is the symmetric matrix, you said. But here you are giving half into A plus A dash is a symmetric, you are telling. Which is correct, sir? Which is correct? We have a doubt, right? Suppose MCQ they are asking general form of symmetric matrix, na? Whether you will select this one or this one is the doubt, right? So for that they are giving note point also. Which one you have to give important? First theorem, what they given? When we have a real entries, you can go. Real entries, real number. Or a complex number, something is there na, you can come theorem number 2. Means 1 by 2 you can multiply. Not only for complex number, here they are telling any square matrix. This will be applicable. Theorem 2 applicable for any type of number. But theorem number 1 applicable only for a real entries. Okay. That is what in the note point they are giving. Okay. Any scalar is there na, you can use like that they are given. Okay. In the textbook page number 64 they are given some explanation. If you want you can use, or else what I give that you can use. Real entries are is there na, this one you use, or any square matrix na, we can go theorem number 2. Right, Raja? Only this is the what is that formulas they are given in the third exercise. Shall we start the sums pa? Sums shall we start? Okay, 3.3 we are moving. Sums we will see in the next video, Raja. Thank you pa. Take care. Bye.